Hey y'all, just wanted to make a quick little review video about some things we've been talking about, and it is about simplifying radicals. So let's go through again how we simplify these. Now the way I do this may not be exactly the way that another teacher is going to do it. This is the way I was taught how to do it when I first learned how, and it has just stuck with me, and it always seems to work no matter what. So if you're simplifying radicals, it really just means you want to reduce them, make them look cleaner than they are, because that means that there's something in there, like a perfect square or a common factor or something that's going to come out, okay? So here's how we do this, all right? I like to look at the factor tree of the number that's under the radical. So 27, you can break that down any way you want. Let's just do 3 and 9. And every time you get to a prime number, we want to circle that. 3 is prime, so we'll circle that, and then 9 can break down into 3 times 3. So what this is saying is that 3 times 3 times 3 is 27. So those are the prime factors of 27. So let's just rewrite this as 3 times 3 times 3 under the radical. And the way I was taught was if you have a pair of the same factor, then the number you have a pair of comes outside of the radical. So there are 3 3s, there's a pair of 3s. So that means the number 3 representing that pair comes outside of the radical. This 3 right here, it doesn't have a partner, so it just gets to stay under the radical. So there you go. 3 square root of 3 is the same thing as the square root of 27. Let's do another one. Let's do the square root of 48. This one you can break down many ways. Probably the best thing to do is just think about the first multiplication fact that you can remember that will multiply to give you 48. If you're having a hard time with that, think about, is it even? If it's odd, if it's even, it always divides by 2. So we'll just start with that. 2 and 24 would be 48. So 2 is prime, can't break it down into anything else other than 2 and 1, so that's why we stop on that side. So let's keep going with 24. Again, there's a lot of different ways you could go here. Let's just go with 8 and 3. That's the first one I thought of. And then 8 we can break down, be careful, into 2 and 4. Sometimes people will put 4 and 4 there, but remember we've got to think of factors, not numbers that add to give you 8. So here we go. 2 more 2s. This one's got quite a few. So let's see, 1, 2, 3, 4 sets of, 4 2s. 1, 2, 3, 4, and then there is a rogue 3 over here, so we will put that back into the square root too. All right, now you're looking for pairs. I see a pair of 2s, so that means there's going to be a 2 to come outside the radical to represent that pair. I see another pair of 2s. So another 2 comes out to represent that radical. Now, I've got 2 2s I brought out. If you bring out 2 numbers to represent a pair, those get multiplied together. And then whatever's left over stays underneath. So actually, this will become 4 square root 3. Okay, so that's how we would reduce that radical. All right, let's keep moving on. Now, we've talked about negative numbers under the square roots, and what this means is that we're going to have an imaginary number. So when you see that negative there, it means, hey, I'm going to have an I in my answer. Start this one the exact same way. First set of factors you can think of that will multiply together to give you 32. Let's just do 4 and 8. And again, you can use whichever ones you think of first. Just make sure they actually work. All right, so 32. Oh, it's just a bunch of 2s. It's 5 of them, isn't it? So I'm going to rewrite this as, I'm going to break that negative down, and then I'll tell you kind of how I will remind you of what to do with that. So we have 5 2s, 2, 3, 4, 5. Okay, so here's where writing that down will help you, okay? So we're going to look for pairs, but let's just go ahead and write what's going to happen because that's a negative. That represents the square root of a negative 1. Now, I know there's not a 1 under there, but I could write a 1 there and it wouldn't change it. So that negative really is represented by my I, my answer. So let's look for pairs here. We've got a pair of 2s. So we're going to have a 2 there to represent that. And then we've got another pair of 2s. So we have another 2 here to represent that. And then there is one little lonely 2 left under that square root. And we want to clean this up some Now, the usual way we would write this answer is to multiply these together and leave your I right next to that number. So 4I and then square root 2. That just makes it look nice and neat. So I after the number instead of before it usually looks a bit better. All right, so the next one is the square root of a fraction. What we talked about in class was the rules of radicals allow us to break the square root up into the square root of the numerator and then the square root of the denominator. And when you do that, you kind of get excited because these are not difficult radicals to reduce. The square root of 49, well, that's a perfect square root. That's just a 7. And then the square root of 25 is 5. So this one reduces to just 7 over 5. And I know y'all don't like fractions, but hey, that's a nice, beautiful answer to me. So we're just going to leave that as is. All right, so that's when you get lucky, when you just have to square root each side, and then it gets, to be a perfect square. This next one we're not so lucky, but it's okay. We're still going to make the best of it. So same process. You want to split this up, square root of the number on the top. And notice how I'm just taking that negative and using it with a 28. Now, we can't put it on both the top and the bottom, because if we had negatives on the top and bottom, remember that would be like saying we've got a negative divided by a negative and that's positive, but that's not true. So negative only gets to go with one of those numbers, and you want to leave it on the top number. It will make it easier. And we don't want i's in the denominator. We'll learn about why that is later. All right, but when I look at this, the bottom, it's looking good. It's a 6. The top, I got to do some work. So let's do a little bit of work on that. The square root of a negative 28. Let's see. 4 and 7 sound good. And then we've got a set of 2's. All right, now I'm doing kind of like a little detour work over here. So let's just look at this down here. So it was a negative. I'm going to bring that negative back over here so we don't forget that we've got to take it into account on this step right here. So it looks like we've got a negative under there. So remember, that represents your I and a set of 2's. So the 2 comes out here. And then there is a little 7 left over. All right, so transfer that back over into your fraction. Alrighty, now this is something that happens sometimes, not a lot, but this one actually can go a little bit further. The reason being is that if I were to take away the I and the square root of 7, that would look just like a 2 over 6, and that is a reducible fraction. So what we want to do is reduce the number outside the radical with a number on the denominator if possible, and both of those will divide by 2. So when you do that, notice I'm not touching the 7, and it doesn't matter if it was divisible by 2. I can't touch it because it's under the square root, and we can't do that. So 2 divided by 2 is 1. You can write 1i if you like. I think I'll just leave it I because the 1 is implied. And then on the bottom, it's a 3. So the I square root 7 over 3 is a great answer. That looks good. All right, for the last one, this one looks kind of complicated, but it's really not that bad. We're simplifying. Now, I can't do anything with negative 5, so bring it on down. But this square root of negative 20, I can clean that up. Well, let's go over here and do that. All right, we can break this down. Let's just do 2 and 10. And then 10 breaks down into 2 and 5. So the square root, again, I'm doing a little detour work over here. The square root of negative 20 is negative 2 times 2 times 5. So we're going to negative and a set of 2's. So it looks like this reduces to 2i square root 5. And all I'm going to do is just bring that over here. Notice I brought the negative down and the plus, and that's a 2i square root 5. Now, the reason why this is your answer is a couple of things. Number one, we reduce this completely. And then number 2, we cannot combine an imaginary number with something that's a real number. Actually, this is called a complex number because it has a real number and an imaginary part. So that's where we're going next. I hope this helps.